So in the previous video, we actually derived until like a transfer function style, right? Like an all this thing. So talk about transfer function, the z plane or the z domain also have its own system of transfer function. Alright, and act totally similar like the block diagrams. I don't think I will need to go through this. Alright, and Mason's rule can also be used in this manner when you combine the stuff. Okay, for info, if happened at 10 years down the road, I forget. Okay, so if it's a parallel system, it's h1 plus h2. This is why over here. If it's a series system, it's h1 times h2. If it's a feedback, it's forward loop h1 over here divided by 1 plus h1 h2 over here, but because this is now a plus feedback, we'll need a minus feedback. Alright, it is how it works for feedback. So if it's a plus, what I will write is minus. If it's a minus over here, then we'll write plus. Okay, reason is if I have input 5 and my output is if I input 5 and I want my output to be 5, however, by going through this transfer function, I have an output of 7. Alright, the reality is 7. Alright, so it feedbacks over here telling that, okay dude, you're gonna minus 2 in order the next round to actually output a 5. You get what I mean? If let's say so therefore it's minus in this case. I mean, yeah, it shouldn't be minus. I mean, it should be plus. It means the feedback will tell back the system that your current system is plus 2. So the next round you're gonna go is to minus. Alright, this is why plus 2 is to tell the system, okay, you have plus 2 more than your input. So the next round you have to minus away so that it is better. So 7 minus 2 will become 5. So the next round we will feedback to 5, something like that. Hope this is a quick summary. Let's come to the a bit chim part. Alright, if you still remember, I have acceleration. I go through 1 over s block diagram. I would have velocity as an output, and then velocity go through 1 over s will have a position, if you still remember. So this is second order, go through 1 over s become first order, go through 1 over s becomes 0 order, something like that, right? That's the meaning. 1 over s is like a integration, right? And therefore in this case the integration for the z transform is in other words z minus 1. Alright, it's called the delay because you delay by a bit, something like that. Alright, z minus 2, this means that it's a second, it has a second so-called time shift or second time delay, 2-time delay, which is what we are saying in the previous video. Alright, so it's z minus 1 is simply like a 1 over s. If it's z minus 2, then it's 1 over s squared, something like that of the meaning. Okay, what it means is that, let's say for example, if I were to bring in the input, if you remember, E is input, U is output, right? So if I were to bring in an input EK, alright, that goes through this transfer function and becomes UK plus 1, okay, which is what is shown over here. But however, if you go through z minus 1, this means that you're going to go in the opposite direction. So you're going to go in the feedback opposite direction, which means that the feedback that comes in the previous path is UK, which is the previous output. Alright, this is UK plus 1. Now you're going to go in a different direction, you're going to go back. Okay, so the UK is equals to your EK minus 1 in this case. You get what I mean? So at first is UK plus 1 and EK, correct? So UK go in the opposite direction, so it becomes over this feedback over here, it becomes UK already, right? Because it didn't interact with the EK anymore. So once it goes back and then feedback back into this system where UK plus 1 is gone, you're gonna have a EK minus 1. This is what of that meaning. So in terms of the z writing, EK is in terms of EZ, UK is in terms of UZ. That is yesterday we say last video we said about it. And then ek minus 1 we derive that is z minus 1 ez, alright, which is, if you don't believe me, this is the previous video we derived, right? I didn't cheat your feeling. And this is just how it works. So that's why it's kind of complicated for the delay part. This is called delay, and you just need to know the concept based on what I've just told you. It's going in the opposite direction. You get an opposite feedback. Alright? How this block diagram works is when you can multiply, okay? If I would suggest you multiply the ez in, so you can visualize better. So I have ez plus ez z minus 1, and then bracket, alright, t over 2, 1 minus z minus 1. So this is it. Alright, so I'm just simply multiplying ez into this system. Alright, bracket. So so now you can see better. So ez over here, maybe in a different color, ez is a forward loop that goes into this summation point, plus ez z minus 1, which is ek go through with ez minus 1, something of that meaning. Or in other words, ek can be written as ez, alright? And multiply with z minus 1, you know that z minus 1 is gonna minus the 1, so this over here becomes k minus 1, alright? But this transfer function that shows is only for this one only. Alright, this is only for indication, tell you that ek becomes ek minus 1, that's all. Okay, some at this point, so therefore they are actually adding up each other. Okay, and then multiply with t over 2, which is over this side, and then divided by the feedback system 1. So this whole thing is like a forward loop. Alright, divided by 1 minus z1, because it's a plus sign, so we have a minus over here. Alright, and that's it. Okay, but he actually didn't because, okay, sorry, I shouldn't say that the whole thing forward, alright, because it's just only this part that is forwarding, so it's just 1 over 1 minus z minus 1. Okay, so this whole thing over here is just only this one. So when you, so this this is a good exercise to actually plot out from the transfer function to plot out individually for the block diagram. I don't know whether in test we really need to do that, but if it's needed, then you can just come back to this video and check it out. And hopefully I remember also. So yeah, this is it for the block diagram part. I shall see you next video.